My report is really called How We Do Research, in the interpretation of which they are not sure. And first of all, let me tell you about who we are. I am the co-founder of the Address project. We have created a service that allows us to analyze social connections between people in order to pull out some information from there. I'm going to tell you more about this now. When several people interact with each other, they form a bond. This relationship can be very different. Maybe you are friends with someone, maybe you are subscribed to someone on social networks, maybe you go out to visit someone with your feet. It's all a connection. When there are many connections, the connections form a network among themselves. And the network is analyzed using mathematical and some other algorithmic methods. A brief example. One of my favorite scientists who work in the field of social data analysis. This is a cool dude with an even cooler surname Papa Christ and Andrei Papa Christ. This is an American scientist of Chicago origin, who at some point decided to build a graph of all the people in the city of Chicago. If I'm not confusing anything, maybe I'm confusing people who were brought to criminal responsibility together, who were brought to the police station together. It is this parameter together, two people were arrested together, he singled out for the connection between people. Based on this connection, he was able to construct a graph. Count of people who were together in jail. And then he did a simple enough thing. He was able to on this graph. Well, that is, as I could. Based on the police reports, he marked on this graph those people who were not necessarily in these cases, but in general, about whom it was known that they were shot. Why did he do that? Because, based on this, he was able to predict the probability for all the other participants in the graph that these people would be shot. As you can see, this is the graph. This is some kind of aggregate. Well, in general, people and the connections between them. They form some kind of structure. There is some denser component on the right, and some more sparse community cliques on the sides. In fact, this is a large correlation plate. You can find it in his article. But the point is that he could show that the probability that you will be shot, if you are in this dense bunch in the center, it is much more than 50%, which, as you understand, is quite effective. It's all cool, but how does it apply to us? We use several reasons to do our research. The first one, this is Robin Dunbar's social brain hypothesis. It is concluded. You are for sure. You may have heard about the Dunbar number. Robin Dunbar. This is a British anthropologist who at some point deduced a pattern between the number of individuals that form a group in primates, which form a stable group, the size of this group, and, in fact, the species of primates. Based on this, he found a direct connection, and he was able to extrapolate this connection and predict the value of such an optimal group for a person. It turned out to be 150 people, and all of you can find this famous Dunbar number as a type of 150 people, and there are 3,000 proofs that people form a group of 150 people, and then not. These are not really proofs, they are rather attempts to pull some observations on us on the globe of this theory, but nevertheless, he is engaged in the development of this theory. And, in particular, he studies how this structure works for each person. That is, from what? What kind of 150 people is this? Are there any relatives? Are there any closer, more distant friends in these friends? How are they arranged? Why exactly is this so? How it is related to the specific individual characteristics of a person? This is what Dunbar does and what we took from him from his work. Second, these are graph theories that allow us when we move from a social community that is connected to each other. People who are connected to each other. These are some mathematical algorithms, some mathematical features that allow us to analyze this story. In fact, this is a very good device for solving problems in the spirit of if we have some kind of community of people who have connections between them, how to move away from one point to another in a minimum number of steps, or how to spread some information throughout the network in a minimum number of steps. It is clear that these are mathematical abstractions, but when we talk about a real community, it has direct practical value. In other words, We can use these algorithms to find out which people we need to contact in order to spread information around the community faster, or in order to convince the community, convinced as a whole of the need for some kind of movement. Well, where do we get the data from now? But we will gradually rearrange it. These are virtual social networks, something that Sasha talked about a lot. Facebook contact, first of all, because it is very convenient, because we are working now mainly in Russia, which allow us to build all these amazing graphs. This is, first of all available activity. Who is friends with whom, who likes whom, who reposts whom, writes texts, and so on. Why? Now I'm going to tell you a few specific cases. I started by saying that I am not from Yakutia. One of these rather important cases that we solved was related specifically to the electoral theme. On the eve of the naval elections, which took place in September of the 2017 year, we were approached by guys from a small town near Moscow, who tried to somewhat change the hegemony that had developed there over the past 18 years. A certain ruling party that settled there and did not change in any way as a result of any shifts, they wanted to nominate their candidate, who was ideologically sympathetic to us, so that, accordingly, he would become mayor in this town. They asked us the following questions. They would like to increase the informativeness of residents about a possible candidate. They would like to know about how different residents are, how loyal each resident is to this candidate, if they know at all. And if they don't know how to increase the popularity of this person. If we translate this into the language of what we do, then the first question. This is how effective it is, how to effectively distribute information over the network. The second one. This is how the behavior of individual nodes happens. And the third. Are there any ways in which, within this graph, the minority that represents, which supports the candidate with whom we are working, can become the majority? What have we done? We downloaded all the data from open and social networks and open sources that we could find. We singled out those people who, at the time of the elections in 2 or 3 months, should have been over 18 years old, and those who, respectively, about which the age is unknown. The ages of those we don't know anything about, we were naturally able to reconstruct, because even if you hide your age, you should know that your age is approximately equal to the arithmetic mean age of all your friends. So this information, it's about how easy it is to hide your data. You can hide your data, but your friends and your environment can return the information about you that you are trying to hide. What did we get? We got this picture. We have such a graph of the whole city. I won't be able to show it, because there are many thousands of nodes and connections between them, but this is it. A drawing based on the motives. There are a lot of clusters inside this city, inside of which we were able to determine. We called it yards, small, denser glues. We found several people in each yard. The most popular dude in the yard, some most talkative grandmother, as we call it, and bridges. These are people who connect different courtyards with each other. Accordingly, we have categorized all this, brought it to the form of a table. This is how the whole city looks like. I'm not sure if all the residents are here. The bottom line is that we have noted. We built such a graph, marked all supporters, all opponents on it, and highlighted the gray ones. These are, accordingly, people who are neither supporters nor opponents. And they built a huge matrix, where for each resident of this city there was a set, a bunch of parameters, including how many of his relatives, friends who would like to vote for supporters, how many for the opponent. Well, all of this, accordingly, we were able to use in order to predict the probability that every resident of this city will vote for one or another candidate. As I see it, I'm running out of time. I'm not going to talk about it. In short, we have downloaded all their texts.
That you can grab a little more time, and considering that you're the last one.
Oh, okay. All right. In short, we downloaded all the texts of these people. Why did we do this? Because the dude needed to write an electoral program, but we were able to. In short, we translated all the words into vector space using the word of the century, and up to the century. And this allowed us to identify, first of all, clusters of words and posts that were written by people who were related to problems. And most importantly, these methods allow you to perform mathematical operations with words. That is, in fact, we are. What is depicted here? We were able to find all the words and all the posts that are at the intersection of the garbage and problem vectors. And that's how we put together some relevant, as it seemed to us, hypotheses about what might worry the residents of the city. And found some, conditionally, multiplying the vectors of housing and communal services and problems, we found addresses there. Well, there's like a pipe burst again, on some Commissar Street. Such posts were found. It's all kind of supposed to allow the dude's electoral program to be formed. Initially, I said that we are doing research that, in the interpretation of which we are not sure, the story of the election. And this is very important, in the context of the whole story about Cambridge Analytica, about us, about all the dudes in general, who say that now we will download everything from Facebook, and do it awesome, and your Trump will win. It's not like that. The story about the elections is even theoretically unverifiable, because it is the only one. You can't do an AB test, you can't do an alternate reality situation where there are other dudes, somewhere everything is the same. Only you don't conduct an experiment. Yes, it seems like on some parameters, where we launched our advertising, some indicators have increased. Another single fact that affects the fact that you most likely cannot claim, that your social technologies are increasing everything that is possible and defeating your Trump, is that you, most of you, are in Russia right now. I will explain this with this particular example, when we wanted to find out what the results of our struggle were. How our story with this candidate ended, it turned out that everything was like this. It actually began on the 10th of September, the correct voting day, uniform throughout the country. It also took place in this city. But by about 7 o'clock in the evening, the broadcast about the voting day stopped, and later there was information in the news that changes were detected in the voting process, so the elections were simply rolled back on the spot. Well, like the head of the city was the same person who had been there for the last 20 years. In other words, you can do a lot of cool things, cool research. Well, first of all, you are not even sure that they will help someone, and secondly, well, like you are in Russia. Here, about the second case, just a little bit. This is another story. I don't really want to deal with elections, not only because I'm in Russia, because this is a case that has a lot of ethical and moral questions and doubts that arise. But there are cool cases that we are approached with. For example, we were contacted. I got a call from some city in the Arctic Circle, and they said, dude, help us find an identity. And like, of course, I agreed, because it's unclear what it means, and what they wanted from me. But in fact, we did it all the same. We downloaded all the words, we tried to find some regular patterns that residents of these cities use when describing themselves. In what positive terms they respond in their city, in what negative terms. And most importantly, we have identified some basic people who are responsible for all the traffic in the city. To be honest, it didn't work out much to find some kind of identity based on what people wrote there. But at the same time, this will now be a smooth transition to the finale of my performance. At the same time, we found people who are trend centers in this city, who connect different people, are responsible for all the movement. It's the owners of the local anti-cafe there. These are people who are engaged in some kind of historical photography of the city. Such people. And there was a big social forum. I came to it, talked about the results, and at some point, the guys agreed to call all these people, the most binding, on stage. It turned out that these were people who, despite the fact that they were very moved, they were little acquainted with each other, and most importantly, the city administration knew nothing about them. This is a very important point. What we do, what I think is insanely important, what I do and what I'm going to do next, and want to do. What we help to build a community. We are using these technologies, very mediated, connected with digital traces. We are building a community and helping. And we must and will help people to be more effective in these communities, to make connections between people more saturated and effective. And at the very end, what are we going to do? All people form networks. People who are related to each other, who come to Alice's birthday, who visit each other, communicate, correspond. We are all part of the network. And we are very good at determining which networks are effective and which are not. And we want to come to everyone who would be willing to work with us, cooperate, and help their network, your network, to do effectively. You have a service in which there are users who give information, who interact with each other. Let's analyze this network, find out how information is distributed over this network. You have an organization that has some kind of corporate postscript, and so on. We don't need to know what you write to each other. We can analyze the network work and how the information is distributed. It seems to me the very, very last moment. I see that time is over. The question of ethics. He's very important. What Sasha talked about a lot, what all network researchers who think a lot about. Not only networks, all researchers of digital traces that are now there. What someone is suffering over, tearing their hair, someone is trying to figure out what the future is. Of course, I don't have a direct answer, but there are some principles that we have formulated for ourselves. Actually, we don't have to steal or take your data through intermediaries. It is enough for us to get information about anonymized data. And this is a minimal, very simple guarantee that they will not go further. If I analyze data about how people communicate inside a company, I don't need to know the names of these specific people and what exactly they write to each other on it. I just need a set, a table. I need a table that has a hash, some encrypted set of people and arrows to whom exactly they sent the data. Now, just a second. Waste, so what am I for? This means that I will not be able to resell this data later. Thank you.